All right, well, good morning. Thank you guys so much for coming. I appreciate it. As Jeff mentioned, my name is Vinny DaSilva, and I'm a developer evangelist with Vuforia. And I am here to talk to you guys about a little thing called augmented reality. How many developers do we have in the house? Awesome, cool. How many of you guys have used Vuforia in the past? Great, awesome, lots of hands. All right, so as you guys know, Vuforia helps developers put content into the real world through objects and environments by using advanced computer vision. And when it comes to objects, Vuforia gives developers a lot of options to work with. We allow you guys to put content onto view marks, images, product packaging, all sorts of things. But what all these objects have in common is that they all have intricate visual detail that the computer vision algorithms latch onto. But what about objects that don't have a lot of intricate visual detail? Cars have been notoriously tricky to augment because of some of the surfaces and transparency in the glass. Appliances are manufactured without augmented reality in mind. 3D printing is becoming really popular. Lots of folks are 3D printing parts and prototypes, and they're playing around with augmented reality. And then, of course, we have things like industrial equipment that a lot of people are very interested in augmenting, and things like motors and engines. All of these objects have been pretty tricky to augment in the past. And Vuforia Model Targets allows us to be able to augment these objects based on their geometry. So it allows us to augment a whole new class of objects. And we do this, we allow developers to augment based on geometry by leveraging 3D models. So surface models or solid models. And because model targets detect based on shape, the color of the particular object is not as relevant. And if the object is got a little bit of wear and tear, or it's a little rusty, the experience will still be, Vuforia will still provide a good experience. So we're going to see a quick little video here of what Model Targets looks like in action. And as you can see here, we start off with an initial detection position. We then detect the object, and we start putting content all over it. The technology understands all the contours and the fine details, and the content really sticks to the object. And of course, in typical Vuforia fashion, we work on all the major platforms, all the major players, including HoloLens. And for those of you interested in a very specific list of devices that we work with, please check out vuforia.com. All right, so to make this magic happen, we have to go through a little workflow. Of course, we start off with a model. And you can source the model from a manufacturer. You can get it from the community. You can scan it, or you can make it yourself. Once you have a model, we need to go through a process of prepping the model. So you might need to reduce the polygons. You might need to add some textures. You might need to do some work on the model to make it optimal. Then we define a detection pose. So that way you can give Vuforia a hint as to how the user will be interacting with the object. We generate a target. So we take that model, we take your information, and we generate a data set that Vuforia knows how to work with. You import it into your favorite development environment, whether it's Unity, Xcode, Android Studio, or Visual Studio. And lastly, you guys build some amazing things. Now, part of this process includes a tool that Vuforia is providing called the Model Target Generator. So what we're going to do next is we're going to go through a really quick overview of how the Model Target Generator works and what you guys can expect from a workflow. I have a video displaying. So first thing we're going to do is we have Model Target Generator open. We're setting up a name. We're loading in our model file. We're going to go ahead and create a project. It loads up. First thing here we're going to do is we're going to set the up vector, because all of these tools have different coordinate systems. And now we're going into the phase where we're setting our detection position. So we're manipulating the object around in the tool. We're finding the optimal position where the user will approach the object from, tweaking it just right. And now we're setting the detection position. And you'll notice on the right side, we have what's called a guide view. This is a tool that we're providing for developers, so that way you guys can better orient and provide a user experience for the user to approach the object from the optimal angle that you're expecting them to work with it. Oh, the video restarted. All right, now we're generating our target, and now what we did at this point here is that we've taken the model, we've taken in information and configuration, and we're generating some kind of a package, so something that you can import into Unity or another development environment. So the file got created. Now we're going to swap. I'm having some trouble here with the video. All right, so I'll just talk through it. So once your package is generated, you're going to import it into Unity. And then you're going to go into using Unity's tools with Vuforia. Now that we're integrated, you're going to create your model target, and then you're going to specify in your model target that you're pointing to that particular package. All right, so that's kind of roughly the workflow that you're going to go through. And now we're going to show you some examples of what some of our customers have done with model targets already. So earlier this year, Mattel announced the 50th anniversary of Hot Wheels. And to celebrate, they're launching Augmoto, which takes a pretty classic racing game and sort of brings it to millennials with Bluetooth, augmented reality, and a bunch of other cool tech. And what we see here is by combining all of these technologies, we're providing what I feel is kind of like a Mario Kart type of gameplay on an actual physical product. And we have a quick little demo at our booth, and I encourage you guys to stop by and check it out. This will be available, I believe, for the holiday season. All right, so also early this year, Mercedes launched an app called Ask Mercedes, and it gives the car owners a digital AR owner's manual. So that way it explains all the functionality and all the features of the car. And this also you can try out in our booth. We actually have a Mercedes there for you guys to play with. And it's really cool and interesting technology. All right, so another car example. Here we have a car configurator. And you'll notice that you can sort of change around the color of the car. And then you can also apply some decals. Now, the illusion here is very convincing, as the content really sticks to the car. If this was floating around and it didn't feel quite right, it wouldn't be a really convincing experience. But here you can see that we're placing these decals, they stick, they feel really solid. Toronto General Hospital has a group that created this educational experience here, which takes a 3D printed human heart and overlays all sorts of information explaining the human anatomy. Now, so those are some fun examples, and I'm sure a lot of you guys want to have your projects up there as examples. So what we're going to do now is we're going to explain to you guys some best practices of what it takes to make a really fun, interesting, or compelling experience using model targets. So to start off with, we got to think about the physical object. So we ask ourselves, what makes a good physical object? Well, for starters, we're looking for objects that has a lot of geometric detail. So things like computer monitors or basketballs won't make very good model targets. And as with a lot of computer vision, sharp edges work better than rounded edges. And because of the way the technology works, you want to keep the number of moving parts or articulating parts to a minimum. And also consider the surface area. So if we're looking at a very thin or skinny object, it doesn't give the algorithms a lot to work with to detect and augment the object in real time. Also, the current algorithms are tuned for objects that are fairly static. So you don't want a lot of movement happening with the object within your scene. Lastly, avoid extremely shiny or transparent surfaces wherever possible. Now, what makes a good digital model? Well, for one thing you can start off with is shooting for under 100K polys to keep the frame rates reasonable and experience smooth. Also, if at all possible, consider using different materials on your model to differentiate different parts of the object. Also, remove any unnecessary geometry. So any articulating parts or transparent parts, you can remove. So when it comes to transparent parts, if the human eye can't quite see it, the computer vision algorithms won't be able to see it that well either, so it won't help us. Just remove that geometry. And of course, you want to use one of our supported file formats. OK, so we have our object, we have our model. Step number 3 here is going to be defining a good optimal detection position. So detection position is the approach which the user will use to interact with your object. So one good tip that we have is if you have a large object, consider using a smaller portion of the object as your detection position. Example is the Ask Mercedes app that you'll see on the show floor. Instead of detecting the entire dashboard, we're only detecting the center console. And once we detect the center console, we can augment all around it. You also want to make sure that your detection position has a lot of geometric features. Again, goes back to how the system works. And you want to make it feel natural. If you're expecting the object to be on a table, you want your detection position to be in such a way where the user is above the table. So you want to consider that angle. If you guys are working on a HoloLens, remember, the HoloLens isn't a handheld device. It's a head-worn device. And the camera is actually further away from the object. It's also up higher. So if you're looking to use HoloLens, consider that the angle is going to be steeper, and the object is going to be further away from the user. I'm sorry, the object will be further away from the camera. And we've also found out that in general, when you're looking at an angled pose, so like where you see part of the front and the side, works a lot better if you're looking at just directly from the side or directly from the front. Lighting, lighting, lighting. Lighting is a huge challenge for computer vision. As usual, you're looking for diffuse, even lighting as much as possible. Very bright or dark spots in your environment can interfere with exposure in a camera, so consider that as well. Lighting should remain pretty static. Keep those disco balls away from your models. And if at all possible, give preference to stable indoor lighting over changing outdoor lighting. So I find it really awesome that Model Targets works with objects that can be several meters big. Now, when it comes to smaller objects, the technology is not the limitation, but what you'll generally find is that cameras on phones and devices can have a hard time autofocusing on very small objects. So we found bigger objects to work a lot better, bigger than 10 centimeters or so. The field of view is also something important for you to consider. If you're talking about a very tall object, you might want to guide the user to using portrait mode. If you have a very wide object, consider guiding the user to using landscape mode. If the object is very big, again, consider using or detecting a smaller portion of a very big object. If you have a very big object, the user will naturally step back from this object to fit it in the field of view. So you want to consider that as you're sort of designing out your experience. It's also really important to make sure that as you're going through the process of generating your target, that you specify the correct scale in the model target generator for the best performance. All right, so a couple more design considerations for you guys to think about. Now, with any user experience, you always want to make sure that you keep the user updated as far as what's going on in the state of your application. So if you're having a hard time detecting something, make sure that you provide that feedback to the user so that way they can adjust and also participate in the success of the application. One thing that one of my colleagues had mentioned is the possibility of pairing model targets with view marks. And what's interesting about this is that with model targets, we can detect a specific type of object. So let's say a specific type of coffee machine. But if you pair it with a view mark, because we can store data in it, you can identify the object down to serial number. So not only do you have the object that you're augmenting, but now you have a specific instance of that object that you're working with. And as mentioned before, well-controlled lighting can greatly improve experience whenever possible. And please, please experiment. This is a pretty new feature with a ton of potential, huge potential, and we're really looking for feedback from the community and developers so that way we can understand what kind of problems you're running into and what kind of objects you're trying to augment. All right, so when you guys came in today for AWE, I'm sure you guys were not expecting a quiz, but I promise this will be fun. And if you guys happen to get all of these correct, we're giving away brand new, limited edition high fives at our booth. And I encourage you guys to stop by and pick it up. OK, so here's Benchy and here's the Millennium Falcon. We have two objects, and I'm going to ask you guys, what do you guys think is going to make for a better AR experience? For those of you guys not familiar with Benchy, Benchy is a pretty typical object that 3D printers will print to benchmark the printer. Now, quick show of hands, who here thinks Benchy might make a better model target than the Falcon? Put your hand up for Benchy. All right, got a couple. How many of you guys think that the Falcon would make a better target? All right, and you guys are correct. The reason here is that Benchy, the default printing size is actually pretty small, so the cameras might have a hard time focusing on it. It also doesn't have a ton of features, and it has some rounded edges. The Falcon, on the other hand, has a lot of geometric detail to work with. All right, so while I have not personally augmented either of these, let's go through a quick little experiment here of what you guys think. We have Iron Man and we have the cap. Who thinks here the Iron Man would make for a better target? All right, and who here thinks the cap? All right, so this one a little bit tricky. In general, I would say Iron Man will probably make for a better target, and the reason is that there's a lot of geometric detail there to work with. But if these are action figures, neither are probably going to make really good targets because they articulate. But if these are statues or busts, I would bet my money on Iron Man. All right, so here we have two scenes. These are two beautiful Japanese-inspired homes. And we're going to talk about lighting. So which of these environments do you guys think would make for a better environment for augmented reality? So we have Exhibit A. Who thinks Exhibit A would be a better environment? All right, and who thinks B? All right, you guys are good. A, while beautiful, might not make the best environment because there's these gorgeous, beautiful windows. They're going to let a lot of light in, and throughout the day, it's going to change the lighting. So it might impact your performance of augmentation. Also, B, it looks to me it's pretty evenly lit. There's a particular area over there by the painting that seems like it might have some bright spots, but in general, it seems pretty evenly lit. OK, this is a tricky one. We got two cars. I believe this is a Chevy Bolt and a Vet. So how many of you guys think that the Bolt might make for a better experience? Put your hand up. All right, and how many of you guys think that the Chevy? I'm sorry, the Corvette. Okay, so this is a really tricky one. It's actually the bolt, and the reason is, it's hard to tell, but the vet is actually on a rotating platform. So what happened, yeah, I tricked you guys. So what happens here is that, as I mentioned before, the algorithms are tuned for fairly static objects, and if you're trying to augment something that keeps rotating, it might confuse things a little bit. All right, so here we have two detection positions. We have the same object in two different poses. How many of you guys think A would make for a better target, better position? All right, and B? And we're going to be giving away a lot of high fives. OK, so A might not work out so well because, in general, like I mentioned before, straight on sideways angles don't work that well. It also reduces the surface area that we have to work with, right? So B here, we have this angle that has a ton of features for the algorithms to work with. All right, another fun one. Alien and the predator. Who thinks the alien might make for a better target? All right, and how many of you guys think the predator might make for a better target? OK, cool. Can't trick you guys. So here, a couple things. So the alien is all one color, has a lot of long, thin appendages, not a lot of sharp edges, except for maybe those talons. The predator, on the other hand, has this iron helmet, has this, all this equipment, multiple colors, also has a lot more surface area, has a thicker torso. So if I were to bet on a bust of, or a statue of either of these, I would put my money on the predator. But I like to think that Ripley is really the real winner. OK, so that's some best practices of how to make the most out of model targets as we have it today. Vuforia is currently working on a technology, the next generation of model targets, right, which is model targets with advanced recognition. And we're going to show a couple things here. So as you guys saw, the current generation of model targets requires a very specific detection position. And what we're doing now is that we're layering on top of model targets deep learning, which allows us to be able to detect objects from various angles. And in addition, it also allows us to be able to detect multiple objects at the same time. And right now, we're looking at about 100 different objects in the scene at once. So as you saw, as you're sort of panning over, we're detecting the object, we're swapping in a detection position, and then relatively quickly, it snaps right in. So this is available in early access today. And if you guys are interested in playing around with it, I encourage you guys to either stop by our booth and check it out yourselves. You can also join our innovator program that allows you to have access to our early access program. So model targets is available today. If you guys haven't played with it, I definitely encourage you guys to try it out. You can download our SDK from our website, or you can download Unity, which includes Vuforia. You can also grab some samples from our website or from the Unity Asset Store. We include, the samples all include this Viking lander that you can 3D print yourself, or you can have it printed by a third party. And for those of you guys that are interested in our next generation of model targets, stop by our booth, talk with us, and join the innovator program to have access to it right away. And that's it. Thank you guys so much for your time. Appreciate it. I think we got some time for questions. Let's do some questions. Go ahead.
How do you find the 3D model tracking on large objects at a distance?
In general, really good. So we've done a lot of work with obviously with cars. We've done work with generators. The performance works really well with larger objects. In general, objects should remain static, as I mentioned before. And any kind of visual features in the environment will contribute to the robustness of the tracking.
Did you find any advantage to having a skin on the model that you're tracking? So say the car's sign written, and that's part of the OBJ file?
Yes, so if you have textures and you opt to use them, we will leverage that, and it will contribute to the performance of your experience. Not necessary, but if it's there, we will leverage it.
What's a high five?
High five. Fist bumps work too. Yep.
For devices that have depth sensors in them, do you use any depth sensing information to try to extract 3D features?
We do not. So the Vuforia technology uses a single RGB camera.
You mentioned it works on US Windows platforms. Does it also work on Windows 10, like, for example, pass-through from like a Live Pro?
It works on handheld devices. So Surface Book and Surface Pro. We have an upcoming technology that uses external cameras that might work with a Vive, but it's something that we're still exploring. Oh, yeah, sorry. Yep.
Have you tried it on buildings?
So the question is, have we tried it on buildings? I have not personally, but because there's a ton of parallel lines in buildings, it may not work that great. But my general recommendation is experiment with it, because sometimes we're surprised by sort of what we don't think is going to work and ends up working really well. Except for experiment, please. I think that's the most important part. Yep.
Maybe I missed it, but you said it works well with larger objects. So does that mean as you're panning and you leave that like approach view, that it's still maintaining connection?
So the question was, when it works with larger objects and you pan the camera away from the object, will the object still remain in place? So the answer to that is yes. So Vuforia has a technology called extended tracking that we leverage with a lot of our other objects. And Model Targets, by default, leverages extended tracking. So if an object, if you initiated an experience in a particular spot and you happen to pan the camera away or move it away, it will stay there until you move it back. Now, if you sort of move the camera to like a white wall without any features, it might confuse things a little bit. But in general, when it comes back, it snaps pretty quickly.
With view marks, I seem to remember there was a rating on your mark. Like, oh, this is a good detect, something to detect. There's something similar with view marks.
So I believe when you're generating the target, there's no information. But part of the tool set that we provide with model targets is a model target tester, which you can use. So you can generate your model, load it into the test tool, and then experiment with it and see how robust the tracking is. Yep.
Imagine a heavy machinery maintenance project. What if operator removes cover and so tracking will be lost? I need to upload another CAD model and recognize from beginning, or it will work.
So the question was, in cases where you're doing some kind of work instructions and as part of the work instructions, you move something away and change the geometry of the environment. So it depends on your use case. What you might want to do is you might want to track a smaller portion of that object that remains static. Or if you know ahead of time what the different models are going to be, you can prepare it and load the appropriate model as you go. It really depends on your use case and sort of the experience you're trying to drive at. But both of those should work. All right, cool. Thank you guys so much. Appreciate it. Have yourselves a great AWE.